This is ELEC120, problem sheet 1, question 2, part E. It shouldn't be called part E, but it's the final part. So here we've told if the electric field as a function of R, so R is the distance, remember, is given by ER is equal to R squared plus 3R. What's the potential function VR, given that we have the condition V of 1 is equal to 2? Now this looks like a horrible question to begin with. The key to this is remembering that if you integrate the negative of ER with respect to dr, you get the potential. So all this is essentially asking you to do is to perform an integration of the electric field, and then that will give you the potential. So if you remember, the electric field is in volts per meter. If you integrate it, then you end up with it in meters essentially. So we're going to substitute E, which we're given, into our integral, perform the integration, and then we get this negative, remember, because we've got a negative kicking around here, and then we've got our constant of integration, C, which we need to calculate. So this is just really basic mathematics. The key point here is if you can realise that you need to take this step, you are most of the way to getting there, you really are. So now we've got an expression for our potential V of R, but we need to find C. We're told in the question if V of 1 is equal to 2, then we can use that to find the equation, the constant. So if you put your value of 1 into each of these and you find it's equal to 2, you find that C is equal to 3, so that's the constant. So then you can just write your final expression, V of R is equal to R cubed over 3 plus 3R squared over 2 plus 3 in volts. It's a bit of an odd way to present an electric field. Sometimes you will come across this. It's presented as a function, because this is normally when it's an irregular shaped field or something weird is going on. In most of our lectures we look at perfect circles, and that can cause confusion. As we go forward, we're going to look at much more complex shapes and different applications, and you'll see why you may have electric field described as a function as opposed to something a lot more simple. So that's the end of problem sheet 1. Like I said, all of those are taken from past exam questions, so if you got through those and you understood what you did, well done, you're well on your way to passing the module.